Hello everyone, I'm Mr. Pinola, and today we're going to take a look at something that we had talked about last class, and that is friction. Friction in much the same way that if I try to slide my hand across this whiteboard, I feel a force working against me as it slides. It's not that it slides really easily, there's a little bit of a force going against the motion of my hand. And so we learned the other day that friction is a force that acts the opposite direction as an object's motion or intended motion. Friction is a force that acts in the opposite direction as an object's motion or intended motion. In other words, if you're moving one way, friction is working against you. Or if you're just trying to move one way and can't, friction is the force that is holding you back. So there are 4 types of friction that we learned about in our last video. 3 of those types we focused on specifically in that video itself. The first is static friction. You might remember I tried to move the refrigerator, but I couldn't, and that's because static friction was acting in the opposite direction. So static friction acts on objects that are at rest and are trying to move, but still won't budge. Then we had sliding friction. When I was moving my hand across the whiteboard, there was sliding friction acting against my hand. The hand was in motion, but there still was a force acting in the opposite direction as the way the hand was moving. Sliding friction also happens when something is sliding across the ground, even if somebody has already let go. We also saw that there is something called rolling friction. Rolling friction usually acts in similar situations as sliding friction, but rolling friction occurs when you specifically have wheels on the object, or you have 2 objects kind of rolling against each other. Usually rolling friction is a value that is lower than that of sliding friction. And that's because objects that have wheels that are moving on their own will experience a little bit less friction than an object that is just sliding across a surface with its entire surface area exposed. But then we talked about the fact that there was a 4th type of friction. And that 4th type of friction is fluid friction. And today, we're going to focus exclusively on fluid friction and discuss what it is and show some examples about when fluid friction would act on an object. So, fluid friction. Well, to understand what fluid friction means, we have to take a look at this word. Fluid. What is a fluid? A fluid can be defined as anything that flows. If you have flow, then you have a fluid. For example, water in a river might flow downstream, or air might flow over the wings of an airplane. So what you're seeing is that a fluid can mainly be one of 2 things. Fluids can be liquids, kind of like the water that was in the river that would be flowing, or you could have maybe some soda that would be flowing out of the bottle when you pour it into a glass. Or a fluid could be gases, such as air. You could have airflow. If I breathe through a straw and I blow into it, I will blow a current of air. And so that air is a fluid. It is flowing through the straw. Even if I do it without the straw and I just blow a stream of air, that is a fluid that's flowing. And air is a gas. just like many other different types of gases that you might experience. So liquids and gases would both be considered fluids, and when you are traveling through a liquid or through a gas, you will experience fluid friction. So let's now take a look at an example of fluid friction. Here you'll see that I have a container that I have filled with water. Remember, water can flow, so it is a fluid. Now, if I take this spoon and I swirl the spoon in the water, the spoon will be a little bit difficult to move through the water. I can still do it, but I can feel the water pushing against the spoon. It is pushing against the motion of the spoon. So if I were to spin the water inside the bowl in a counterclockwise direction, then the fluid friction would be acting in a clockwise direction, acting against the motion of the object in the liquid. So there is fluid friction preventing the spoon from moving through the water. So we just saw an example of fluid friction, which is kind of like a spoon that was moving through water. Now, you could also have fluid friction if you were going through a different type of liquid. So for example, if the liquid inside the bowl were, let's say, honey, then it would take a lot more work to move the spoon through. You would really notice the difference. But in both cases, it was a spoon moving through a liquid and it experienced a little pushback. And so that was an example of fluid friction. But you might recall that fluid friction is not only about liquids, it's also about gases. Specifically, what's around me in the room right now, air. So because of that, fluid friction can sometimes take a couple different names. It can be called fluid friction, just like we've been discussing. However, since a lot of times fluid friction takes the form of air working against an object's motion, we oftentimes will call it air resistance. That word resistance means working against, and the air would be working against an object's motion. Or sometimes we hear it called drag or air drag, which would be working against something that is moving through air. So whether you hear the word fluid friction, air resistance, or drag, you'll know that all three of these terms could represent a type of friction that is working against an object moving through a gas, such as air. So let's call fluid friction air resistance. Did you know that there are going to be a couple different factors that will affect how much air resistance you feel? Let's talk about those factors for a moment here. The first of those factors is speed. How fast are you moving through the air or through the liquid, like when I was moving my spoon through the water? Well, it's actually true that if you increase the speed, that you are going to also increase the drag, or the amount of air resistance or fluid friction acting on an object. A good example is to think about if you were riding a roller coaster. If the roller coaster is moving really slowly, you don't feel a lot of air in your face. But if the roller coaster is moving really fast, say 60 miles an hour, you would feel the air whipping against your face, and it would feel like you were really moving through that air really fast. It would almost feel like there was some wind going against you, even on a day that wasn't windy. Think about it as well if you were driving in a car and you stuck your hand out the window of the car. If the car was moving slowly, you might feel a light breeze of air against your hand. But if the car was moving really fast, such as on the highway, then you would feel a lot of air pushing against your hand. So when speed goes up, the amount of drag that you feel goes up as well. And that's because the faster you go, the more air resistance there is. second factor that affects air resistance is surface area. By surface area, we mean the area of an object that is facing the wind that is working against it, or is facing the air that is working against it. For example, if I was to drop this piece of paper and I were to drop it flat like this, it would have this whole area moving in the direction downwards that it was going. And so air resistance would have to push against this whole underside of the paper. But if I dropped the paper on its side, it would slice through the air a lot easier, because only this bottom part would be the surface area that would be working against the air resistance in this case. So that's why when you drop a piece of paper like this, it experiences a lot of air resistance as it falls. And that's because as the surface area, which I'll abbreviate SA, goes up, the amount of drag or air resistance or fluid friction will increase as well. So when you drop a piece of paper like this that has a big surface area underneath, there's a lot of air drag, and so it doesn't fall down that fast. But when you drop the piece of paper like this and you allow it to slice through, now surface area is really small, and it cuts through the air really fast as the paper falls downwards. So a couple things that we can see so far: making the speed bigger would make you feel more air resistance, and making a bigger surface area would also make you feel more air resistance. So can you think of an example where something would be moving really fast and have a really big surface area, and therefore there's a lot of air resistance? Well, maybe you've been skydiving in your life, or maybe that's something that you want to do one day. Let me draw a diagram of a person skydiving. We'll make him surprised because he's scared as he's moving downwards. Usually somebody that's skydiving doesn't go skydiving by just jumping out of a plane without any other kind of material with them. Usually they have a parachute attached to their body. And so I'm going to draw a parachute here in the green attached to this man's body as he skydives and falls downwards. Well, what do you notice about the parachute compared to his body? It's a really big surface area. This whole area of the parachute is very big compared to the area or the surface area of the man. That means that as he falls, he would experience a lot of air drag or air resistance because of the big surface area of the parachute. He would also be moving really fast as he falls through the air after jumping out of the plane. So when the man is about halfway down towards Earth, he will be moving really fast, and when he deploys his parachute, he will have a lot of surface area as well. That will mean that the man will have a lot of air resistance or fluid friction acting against him. And that's going to cause him to eventually slow down. And that's why when you skydive, if you use a parachute correctly, you can land on the ground with a really slow speed. And that's because the air resistance is going to work against you. You have a lot of air resistance slowing you down to a much safer speed for the moment that you hit the ground. There is one last factor that affects the amount of air resistance that something feels, and that is the thickness of the fluid. We talked about this earlier when I showed you the example of the container of water and I tried to move the spoon through it. When we had our container of water and we moved the spoon through it, it was fairly easy to do, but I still felt a little bit of the water working against the spoon. But what if this were a really thick liquid, like honey or molasses or cake batter, which can flow if you were to tilt the pan in the right direction? Then it would take a lot of work to move the spoon through. Maybe you've done that if you've ever done any baking. It takes a lot of force to move the spoon through the cake batter when you're baking a cake. And that's because the thicker the fluid, the more air resistance or fluid friction in this case, you will experience. It also works with air. But how can air be thick? Well, maybe you've heard that there's really thin air at the tops of mountains. For example, in the state of Colorado, when you go to the mountains and you go climbing in the Rocky Mountains, the air gets very thin. And that's why some people have trouble breathing at very high elevations. Well, if you're a sports fan, maybe you've heard of the Colorado Rockies, who play their home games very high above sea level. They play their games almost 5,000 feet higher into the air than the Boston Red Sox would do around here. And so when the Rockies play and they hit a fly ball to the outfield, that baseball, as it flies through the air, would experience air resistance or air drag. So here's my baseball. If the person hit it and it's flying through the air, there's going to be a little bit of air resistance or drag working against the baseball. I'll show that with the blue arrow and indicate that as drag. Well, when the baseball travels through the air in Denver or in Colorado, where the Rockies play, now the air drag is going to be less because the air up there is thinner. There would be less air resistance working against the baseball, and the baseball would be able to travel further. And that's why you may have heard that the Rockies, when they play at their home games at Coors Field in Colorado, they hit a lot of home runs. And that's because there's less air resistance or drag or fluid friction working against the baseball when it's flying. That's because the air is thinner. When you have thick air or a thick fluid, you will experience more air resistance, air drag, or fluid friction, depending on what you want to call it. So I hope you learned something today about fluid friction, which is the fourth type of friction that we discussed. Fluid friction works against objects that are moving through either a liquid or a gas. So if you're swimming or walking through water, you can feel the water pushing against you. That's fluid friction. Or if you're riding your bicycle and you feel the air pushing against you, even on a day that's not windy, that's fluid friction working against you. And remember, the faster you move through the fluid, the more fluid friction you'll feel working against you. And the bigger your surface area, the more fluid friction you'll feel. That's why you might see some cyclists put their head down like this and grip onto the handlebars. They want to make their surface area very small so they cut right through the air. That's the same reason that when an airplane wing is designed, it's designed in such a way that the air can flow through it really easily. They don't want to generate, or they don't want to have a wing that's too flat on this far end, because then there's going to be way too much air resistance as the plane is moving.